Did you know that the discovery of vulcanized rubber by Charles Goodyear in 1839 revolutionized the tire industry? This accidental discovery set the stage for modern tire manufacturing. But it wasn't until the early 20th century that air-filled tires became common. Fast forward to today, and tire production has become a high-tech process. Factories around the world produce over 250 million tires each year. Let's break down the steps involved. Before a tire is approved for mass production, engineers design it using specialized computer software. Tire engineers can model tread designs and other factors with the help of this software. It estimates the impact of various stresses on the suggested design and produces a three-dimensional color picture of a possible tire design. Tire producers can save costs by using computer simulations to discover design limits before the assembly and testing of a prototype tire. Once the design is approved, the manufacturing process can begin. 10 to 15 separate parts make up a modern tire, including pigment called carbon black, chemical additives, and natural and synthetic rubbers. Rail carriages deliver these supplies to the factories where they are stored. Subsequently, a Banbury mixer is used to combine particular batches of rubber and chemicals that have been measured by computer systems. Two intermeshing rotors are housed inside a large, cylindrical mixing chamber that makes up the Banbury mixer. The rubber compounds are heated in the mixing chamber prior to the start of the mixing procedure. Heat causes the rubber to become softer, more flexible, and simpler to combine with other substances. Upon chamber heating, the rotors begin to rotate counterclockwise. Shearing and kneading are created inside the mixing chamber by the rotating rotors. The rubber and other materials mix together as a result of this motion. For various tire components, there are many formulas, but the end product in every instance is gummy rubber dough, which is rolled into sheets by equipment and left to be further kneaded and processed. For the corded ply, polyester unrolls into a calendar machine equipped with rollers that apply warm rubber to both sides of the fabric. Rubber by alone cannot create a tire that is robust enough, hence this fabric ply is required. Now, bobbins are pulling a plethora of cotton cords into the rubberized cloth. This cording provides channels for venting air during the tire building. The outermost portion of a tire that makes contact with the road is called the tread. Its distinctive patterns and designs are crafted from a specifically developed rubber compound to provide the best possible grip, handling, and wear characteristics. Three distinct rubber formulations are needed to make rubber for tread. The three rubber streams are shaped by extruders and then combined into one by a die. Numerous paint rollers apply stripes in various colors. In this manner, while processing, the factory can distinguish between the various ingredients. The method leaves slack in the feed to prevent strain. The tread rubber is then cut to length with a blade. It's finally time for the tire's components to come together. A worker typically places the bead rings on a unique revolving drum to start the tire construction process. The inner lining is next. Air cannot escape through the tire thanks to an airtight seal provided by the thin rubber inner liner. It also aids in maintaining appropriate inflation and acts as a barrier against moisture. The corded ply is then placed over the inner liner. The tire is strengthened against internal pressure by the corded ply, which gives it strength and stability. The tire has to be beaded in the next phase. Rubber is rolled around the bead on both sides by inflatable bladders, which subsequently retract. The beads are then augmented with sidewalls. These sidewalls are then folded over the beads by tiny rollers. The rubber sidewalls of the tire offer protection and flexibility. They also provide other details including sidewall dimensions, brand markings, and tire size. The tire's inner framework is now complete. Belts are usually wrapped around another drum to start the process of manufacturing the outer shell, which is produced independently. Usually, rubber is embedded with steel or another reinforcing material to create belts. These belts strengthen the tire, increase its resistance to punctures, and offer stability when driving at high speeds. The tire design and performance requirements can affect the number and angle of the belts. The belts are then covered with narrow strips of rubber ply. A computerized system lines them with just the right amount of tension for a graduated effect. Finally, the tread is applied to the ply. The two tire fabrications are now ready to become one. A transferring collects the outer assembly and transfers it to the inner part. The tire is then shaped by compressed air, which causes all of the sticky layers to cling together. The tread rubber's edge is rolled over the sidewalls by a machine. They currently have what the industry refers to as a green tire, which is an uncured tire devoid of tread pattern. It may surprise you to learn that tire installation was done by hand up until 1909. The procedure wasn't automated until Goodyear received a patent for their groundbreaking tire construction apparatus. Depending on the type, this core-building machine reduced and expedited production from 6 to 8 tires per worker-day to 20 to 40 tires per day. To begin the curing process, the green tire is put into a sizable mold. A tire mold resembles a hideous metal clamp that opens to expose a bladder, which is a huge, flexible balloon. When the clamshell mold closes, the bladder expands with steam, forming the tire and pressing the blank tread rubber against the elevated interior of the mold. This is done by placing the green tire over the bladder. The steam raises the temperature of the green tire to 280 degrees during the curing process. In addition to molding, the rubber undergoes a chemical reaction known as vulcanization over the duration of its stay in the hot pressurized mold, which changes it from a weak, sticky material to a strong, elastic one. Excess rubber is removed when it has cured, leaving a smooth and tidy tread surface. After that, a comprehensive inspection is performed on the tire to look for any flaws or irregularities. To guarantee both safety and quality control, this step is essential. Hundreds of tires are removed for destructive testing at the end of the production line when a new tire design is being produced for the first time. For example, some tires are cut open to look for air pockets between body plies, and others are rubbed against metal studs to see how resistant they are to punctures. To measure mileage and other performance parameters, certain tires are spun quickly and pressed against metal drums. The tires go through extra finishing procedures after passing inspection and testing. These include putting on a layer of protective coating, identifying the sidewalls with tire characteristics and brand names, and adding any necessary branding or labeling. The completed tires are ready for distribution after being packaged. Usually, they are kept in warehouses until they are sent to automakers or retailers. Driven by increased technical breakthroughs and expanding demand from developing countries, the worldwide tire market reached a volume of $314.07 billion USD in 2022. The population is still expanding, thus this number will only increase.